This is 2024, Telephone 2, Paper 2, AHL, question 6. So it seems to be related rate is the volume of a bubble. So this question seems to be extremely typical. You have the rate of change of the volume, so that's dV dt, right? And they're asking for the rate of change of the radius, so they want dr dt. So the typical thing to do would be, if you have the rate of change of v and they ask for the rate of change of r, then you want a equation that link v to r. Well, this is a sphere, so the volume of a sphere is 4/3 pi r cubed. I don't think the fact that the initial volume is 0 is relevant. Yeah. So you just get the formula and then differentiate both sides with respect to t. So in some sense, you would do it like it's an implicit differentiation. So you differentiate r cubed, that's 3r squared, and then implicit. So by chain rule, you need to times differentiate the r. If you differentiate r with respect to time, you get dr dt. Then you simply sub in the rate. dV dt is 5. dr dt is what we are looking for. So the only thing that's missing is the value of this r. This is where you use the fact that they want the rate of change of the radius when the volume is 20. So when the volume is 20, if you sub into the formula, you get what? 60 divided by 4, that's 15, right? So it's 15 over pi cube root. So r is that. And then you just divide everything away. You get a you get a value for the dt, and that should be the answer. 15 over pi to the power of cube root, so it's 1/3. Then square, then times 4 pi. Then we have 5 divided by that. If I didn't press anything wrong, it should be 0.140. Question 6, very typical related rate. Question 7 seems to be very typical volume of revolution. This is rotate around the y-axis, so the formula is pi x squared dy. By x squared, we really means you need to go to the equation and make x the subject. So we make x the subject. So we divide by 4. To get rid of the log, you the other side, So x is e plus 2. So the volume is simply, how many mark is this? This is 5 mark. And the height is 0 to 4. So remember, when it's dy, you put in the limits would be the y value, but these are y value already. So and also the fact that this is paper 2, so you can just type this whole thing into the calculator. So we have two extremely straightforward, super typical. It's like you can't even teach the topic without going through examples like these, right? Plus 2 to the power of 2, boom, answer. That's like super boring. Then is question 8. Question 8 is difficult, but it's a classic. It's come out multiple times in the past, like some really old past paper. So so what? 6 and 7 was extremely standard, and then we have a classic, which means it's difficult, but you have probably seen how to do it. So I don't know what to say about this paper now. It's like I can't say it's difficult, right? So the key is this is 1 minus 1, so it cancel out. And then we simply factor out the common factors. Then we have what? We have cosine theta plus I sine theta. Right, the trick is that now this is something in polar form, right? This would be the R, and this is the cosine theta plus I sine theta part, which means we're done. Because this would be the modulus. And whatever the thing inside the cosine plus I sine is the argument. No, theta. Alright. So if you know what to do, it's actually easy. And then part B look crazy. The argument of z squared. The argument of z squared is really 2 times the argument of z, right? De Moivre's theorem, so it's 2 theta. And then the modulus of z cubed is really the cube of the modulus of z. Sometimes that's also De Moivre's theorem. The question wants them to equal. But again, this is paper 2, so your calculator would take care of that. So you can use solver. I just like graphing. 2x. Again, be careful that your calculator should be in radian, because yeah, they're using radian. Cube cosine theta cube. Cube. So where's the intersection? Why is there no intersection? There. Theta is 0.913. So it seems there is only one value, and the other value is already less than negative pi over 2. So there's really only one value. 2024 Samsung 2 paper 2 AHL question 9. This is the last question of section A, and it seems to be quite hard. You're given a local minimum, and you're given a vertical asymptote. So vertical asymptote is when the denominator is 0, but the denominator is a quadratic. So I'm guessing there should be 2 vertical asymptotes, and the question only tells you one of them. But anyhow, that would mean we can at least sub in 1, so we know a plus b plus c is 0. So I guess that's useful. Well, we also know one of the point is 2, 1. That means if x is 2, y is 1. So I guess we can also sub that in. Then we multiply to the other side. No, then we already have 2 equations, 3 unknowns. Oh, then it's not that hard. It's actually quite straightforward. It's just tedious, I guess. Then to find the minimum, we differentiate using the quotient rule. So it's the bottom squared. Then differentiate the top is 1 times the bottom copy minus copy the top, differentiate the bottom, so it's 2ax plus b. For it to be a minimum, the derivative will be 0. And when it's 0, you can just multiply the bottom to 0, so it's gone. The minimum is when x is 2, so you can sub in x to be 2. So now we got 3 equations with 3 unknowns. 2 minus 4 is minus 2. So it's not as difficult as I initially thought. I thought it's gonna be like really tricky and stuff. Oh, this is already squared. 4a. So it's what? This is positive 8a plus 2b. Do we have this already? This is negative 2. So negative 2 negative, oh no, this is negative 2. So we move to the other side, it's positive 2 plus 2b. Then we have 3 equations with the unknowns, and they are linear. So this is something your calculator will be able to solve. Seems like mine cannot solve simultaneous equation. But I'm quite sure your GDC can. So I guess I'll do it by hand. So this is what, 4a plus b. So b is really 1 minus 4a. So this equation becomes a plus 1 minus 4a plus c equal to 0. So minus 3a plus c is minus 1. While this equation becomes 4a plus 2 minus 8a plus c equal to negative 2. So minus 4a plus c is negative 4. So if you do this minus this, we have a being 3. Okay, if a is 3, then from here we have b being negative 11. Then from a plus b plus c is 0, that means 3 minus 11 plus c is 0. So c is 8, I think.